Good morning, class. This is Maria Angelis. In this video, I will be performing a biomechanical analysis of the tennis serve. Okay, so we begin with our introduction. The tennis serve is the only shot in tennis that gives a player a beginning advantage in dictating point play. The serve requires coordination of the upper and lower body segments in order to be performed successfully, so it is considered the most complex movement in tennis. That coordination, known as the kinetic chain, will allow a player to have a sequence of movement necessary to activate, mobilize, and stabilize his or her body segments in order to generate and regulate the force necessary to produce velocity on the ball. There are 3 phases of the serve and 8 stages, and we will delve into these further. For now, I thought it would be helpful to give us a couple of baseline views of the serve before we begin to break it down piece by piece. So this video was recorded at the Veltri Tennis Center. This is an 18-year-old player, and she trains with Nick Saviano. Here we're looking at a couple of her serves, and I'll just let it play. Phase 1, or preparation, begins at the first instant of movement up until the player's shoulder is maximally externally rotated. The start stage of this phase is reflective of a player's style and has little substance. The goal of this portion of the prep phase is to begin to align the body in order to use the ground to generate force and power in the later phases. The release is a ball toss portion of the serve. The toss should be slightly lateral to the overhead position of the serve, or a 2 o'clock position, because it allows for ball contact to occur at approximately 100 degrees of arm abduction. If the toss is too close, it will affect trajectory of the racket to the ball. We're going to cut to some video here to look at the start and release stages before we look at the last 2 stages of the prep phase. Stage 3 can be considered the most important stage of the entire serve. Players position the body in such a way that it generates potential energy due to specific loading positions of the body segments. The player I videoed makes use of the foot back technique, where the front legs provide stability needed for rotational momentum, and the back leg facilitates most of the vertical and forward movement. Resulting serve velocity is a direct effect of the loading phase. Lastly, stage 4, or cocking, allows for further storage and generation of potential energy by facing the head of the racket down and behind the trunk. This generates an extra amount of potential energy because it lengthens the trajectory from the racket to the ball. Phase 2, or acceleration, starts when the head of the racket is facing down and ends when contact with the ball has ceased. The previous stages of the serve determine the amount of acceleration that a player can achieve. I found it interesting to note that in a study involving performance enhancement of the serve, elite players have been found to move from maximum external rotation of the shoulder to ball contact in less than 1/100th of a second. Phase 3, or the follow-through, is notable for the violent deceleration that occurs in both the upper and lower body segments. These will be discussed further in a biomechanical principle. For now, the follow-through is the end of the service motion where internal rotation of the shoulder and forearm pronation occur. Throughout this motion, it is known as long axis rotation. Biomechanical principle 1 of the tennis serve is the storage of potential energy. Stored potential energy in the preparation phase means more available kinetic energy in the acceleration phase. In an effective kinetic chain, the lower segment is the engine that develops the force that accounts for 51 to 55% of total kinetic energy and force delivered to the hand. Knee flexion and back leg drive maximize ground reaction forces and push the body upward into ball impact. A rear shoulder and pelvic tilt in the loading phase is an indication of a powerful serve. This type of alignment builds potential energy for the development of angular momentum through lateral flexion during the acceleration phase, which is crucial for high-velocity serves. Principle 2 is the shift in the center of gravity that happens during the preparation and acceleration phases. The backward shift that occurs in the prep phase causes the tilted alignment that I spoke of previously. This shift in the center of gravity allows the racket arm to extend further behind the trunk and ultimately increases the distance that the racket travels through during the acceleration phase. During the acceleration phase, center of gravity must shift forward in the direction of the ball. This shift in the center of gravity corresponds with the coordination and loading of the upper and lower body segments and will allow a server to create more power and momentum as they shift their body weight forwards towards the ball. The increase in velocity of the serve is directly an effect of the preparation and acceleration phases. It is a buildup of potential energy. Stored potential energy is transferred from the knee to the racket as kinetic energy. Between loading and the acceleration phases, there is a buildup in the ground reaction force, and it results in an elevation of the dominant arm side and a lowering of the toss side. This produces an optimum position from which to allow the player to explosively accelerate through the ball, which translates to increased velocity of the serve. Principle 4, or transfer of kinetic energy, is facilitated through leg drive mechanics. Flexion of the front knee of about 15 degrees or more encourages a more vertical and horizontal force production. The transfer of kinetic energy creates a pattern that is pushed like in nature through the coordination of the upper and lower body segments. Kinetic energy is transferred from the legs to the hips and ultimately to the upper body, in turn enhancing shoulder rotation and increasing the force that is applied to the ball. Principle 5, or the deceleration of joints during the follow-through portion of the serve, is an extremely important stabilization period that occurs in order to minimize the risk of shoulder injury. According to a study done on performance enhancement of the serve during this time, deceleration force between the trunk and the arm can be as high as 300 newtons per meter. This force helps to stabilize the shoulder against distraction forces that are more than half times a player's body weight. Musculature of the rotator cuff and upper and lower back also help to serve deceleration and maintain shoulder stabilization following contact with the ball. Lower body landing also generates high eccentric forces, which are offset by landing of the front foot, as it develops a much larger horizontal braking force as the center of gravity lands forward.